During the teardown of the foam dart gun, I got to thinking about mating wedges. In this problem, we have a 30-degree wedge that mates to a 60-degree wedge, and we want to find the x and y displacement for the x displacement of 5 and the y displacement of 7. And we also want to find the mechanical advantage of this wedge system. How do we go about solving this one? Recall from trigonometry the property of right triangles, SOHCAHTOA, that the tangent of the angle is equal to the side length opposite of that angle over the side length adjacent to that angle. If we are working with a 30-degree angle, our opposite would be the y displacement and our adjacent would be the x displacement. We can rearrange this formula to get what we are solving for, the opposite or y displacement, to one side. Plugging in our values, we get an opposite side length of 2.87 units. So if the 30-degree wedge is moved at a distance in the x direction of 5 units, the 60-degree wedge will rise up a distance in the y direction of 2.87 units. Next, we can use the same tangent equation and rearrange to solve for the adjacent side length, which is the x displacement. Plugging in the y displacement of 7 units, we get an x displacement of 12.12 units. This means that if we move the 60-degree wedge up 7 units, we will need to displace the 30-degree wedge 12.12 units. To get the mechanical advantage, we can take the input displacement and divide the output displacement. This really is 1 divided by the tangent of the angle, which equals the x displacement over the y displacement. We get a mechanical advantage of 1.73. This means that if the 30-degree wedge is the input, the force at the output would be 1.73 times greater than the input force. This is assuming no losses like friction. This greater force comes at the cost of less displacement at the output. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.